Hi students, welcome back to my channel Chemistry with Saranya ma'am. Today I am going to discuss about in the last class we have discussed about heat of reaction, standard heat of reaction, and we have solved some previous year JEE questions. Today we'll discuss what is enthalpy of formation, and what is enthalpy of combustion, and we'll solve some questions. Okay, now we'll get into the topic, that is enthalpy of formation. Enthalpy of formation. So actually enthalpy means it is heat content. So here heat, amount of heat released or absorbed. What is that? Enthalpy is nothing but heat change, heat content. So here absorbed, here the heat change means here the heat may be released or absorbed. So when the amount heat is released or absorbed during the formation of any compound. What is that compound and how much we have taken, that matters here. That is 1 mole of any compound. What is that? 1 mole of any compound. So here it is nothing but enthalpy, heat content will represent with delta H naught. All these are at standard conditions of temperature and pressures. So delta H naught F. So here enthalpy of formation is nothing but it is amount of heat released or absorbed when 1 mole of compound is formed. When 1 mole of compound is formed from its constituent elements in their naturally occurring state. Formed from its constituent elements in their naturally occurring state. Constituent elements in their naturally occurring state means, here for example let us take the formation of H2O. So it is formed from its constituent elements, that should be 1 mole. Okay, if 1 mole of H2O is formed from its constituent elements, means here H2 plus half O2. These two are its constituent elements, no? In their naturally occurring state. Hydrogen and half oxygen, H2O. Here, whatever the amount of heat released, that is nothing but enthalpy of formation. Okay, let us take CH4. If 1 mole of CH4 is formed from its constituent elements, carbon in the graphite form, plus 2H2, whatever the amount of heat released or absorbed, that is nothing but enthalpy of formation, standard enthalpy of formation. Let us take the formation of C2H5OH. When 1 mole of C2H5OH is formed from its constituent elements, carbon, graphite, 2C plus 6 hydrogens, 3H2 plus half O2. When 1 mole is, the condition should be 1 mole. When 1 mole of a compound is formed from its constituent elements in their naturally occurring state, then whatever the amount of heat released or absorbed is nothing but enthalpy of formation. Clear? So if you observe, in the previous class I have discussed about heat of reaction. What is heat of reaction? Delta H naught R, standard heat of reaction. Here, amount of heat released or absorbed during any chemical reaction is nothing but heat of reaction. If the standard conditions are taken, that is standard heat of reaction. So here, can I say one thing? Here, what is enthalpy of formation? Here, amount of heat released or absorbed when 1 mole of a compound is formed. Okay. So, here whatever the amount of heat released is nothing but heat of that reaction. No? So, can I say delta H formation is equal to delta H reaction? Yes? Yes. Okay. So here delta H formation, enthalpy of formation is nothing but enthalpy of reaction. Clear? This is enthalpy of formation. When 1 mole of a compound is formed from its constituent elements in their naturally occurring state, whatever the amount of heat released or absorbed is nothing but enthalpy of formation. It is represented by delta HF naught. Okay? Clear? Okay. Next we will discuss what is enthalpy of combustion. What is first? Let us see what is combustion. Combustion means burning in presence of excess of oxygen. Burning with oxygen. Excess of oxygen. So here combustion means burning in presence of excess of oxygen. So here whatever enthalpy means, all these are very simple definitions. Okay, enthalpy means heat change. So amount of heat released or absorbed. Here always energy is released because it is an combustion. Okay, so amount of heat released when, what is the condition? When 1 mole of a compound is burnt or combusted in oxygen. Here what is the condition? For enthalpy of formation, whatever the compound formed should be 1 mole. And for enthalpy of combustion, the whatever compound you are taking for the combustion should be 1 mole. Clear? For example, H2O formation. Here in the product side it should be 1 mole. From its constituent elements H2 plus half O2. Here we call it as whatever amount of heat released, that is enthalpy of formation from its constituent elements. Now here for example let us take CH4, hydrocarbon. When hydrocarbon is, any hydrocarbon is burnt in presence of oxygen, gives always the products are CO2 plus H2O. What is our condition here? This should be 1 mole. Got the difference between this? We call as whatever the amount of heat released, we call it as enthalpy of combustion. It is represented with C. Okay, got the difference between this 1 mole. Here product side should be 1 mole during the enthalpy of formation. Reactant side should be 1 mole during the combustion. That is the difference. Here always during the combustion always amount of heat will be released. Whatever the amount of heat released in the chemical reaction, that is nothing but heat of reaction only, which is equal to delta H naught of combustion. Okay, so here it is the amount of heat absorbed or released when 1 mole of a compound is burnt in presence of combusted in presence of oxygen. That is enthalpy of combustion. So what we have discussed till now: heat of reaction, standard heat of reaction, delta H naught R, enthalpy of formation, enthalpy of combustion. Now we'll solve some questions so that this will be more clear to you. Okay. Now look at this question. This was asked in 2022. Okay. So at 25 degrees centigrade and 1 atmospheric pressure, enthalpy of combustions are given below. So substance and enthalpy of combustion: substance hydrogen, carbon, graphite 394 and C2H6 ethane are given. Now he is asking you to find out delta H formation. Here combustion values are given and you are asked to find out enthalpy of formation of ethane. Now what you have to do? So first you have to, I told you no, first you have to write the required equation. What is your required equation? Here for C2H6 enthalpy of formation he is asking. So this should be, what is enthalpy of formation? The product side should be 1 mole. When 1 mole of a compound is formed from its constituent elements. What are the constituent elements? Carbon, 2 carbon, graphite plus 3H2. This is your required equation. Now, this part we have completed. Now, we'll look into the data given. So, he has given the enthalpy of combustion of H2, enthalpy of combustion of carbon graphite, and enthalpy of combustion of C2H6. First, write down the data. So, first we'll write enthalpy of combustion. Combustion means burning in presence of oxygen. So, when hydrogen is burnt in presence of oxygen, what you will get? You will get H2O. What is the value given? That is delta HC0 is equal to minus 286 kilojoules per mole. Okay. Next, combustion value of carbon. So, carbon graphite burning in presence of oxygen, oxygen half O2, H2O. So, carbon, oxygen gives rise to CO2. What is delta HC combustion value here? Delta HC naught is equal to minus 394 kilojoules per mole. Now, enthalpy of combustion of ethane, you write C2H6 plus O2 gives rise to, I told you, no, when hydrocarbons are burnt, always the products are CO2 and H2O. Now balance this equation. 2C, here also you should write 2C. And 6 hydrogens, so here it should be 3H2O. Now, how many oxygens are there? 2. 2 2s are 4 plus 3, 7. So, 7 divided by 2. 14 by 2, 7 oxygens. Okay. Next, what is the combustion of this one? Delta H naught C is equal to minus 1560 kilojoules per mole. Okay. Now, you have to look for the required equation. From these 3 equations, you have to write the required equation. So, here, how to get here in your required equation? The same procedure. 2C is there. So, you multiply the second equation with the 2. 2C plus 2O2 plus 2CO2 plus 394 into 2. Okay. 3H2 is there. So, multiply this one. 3 by 2 H2, 3 by 2 O2, 3H2O. Okay. This will be into 3 kilojoules per mole. Now, in your required equation, this 1 mole of ethane is your right hand side, but in this equation it is this side. So you just reverse this equation. When you reverse this equation, the sign will change. So here you reverse this equation. 2CO2 plus 3H2O gives rise to C2H6 plus 7 by 2 O2. So what is the sign? The sign will be changed to plus 1560. Okay, I'll write here only. I'll reverse this one. Now look for the cancellation. This 2CO2 will get cancelled. And 3H2O will get cancelled. 3 by 2 O2, 2 plus 3 by 2, which will be equal to 7 by 2 O2. 7 by 2 O2, 7 by 2 O2 will get cancelled. Now what you left with? You left with our required equation, which is 2C graphite plus 3H2 gives rise to 1 mole of, no need to write that one. So we got our required equation. Now clear this one. We want to find out this value. Enthalpy of formation he is asking. How you got this from all the above data? So here enthalpy of formation is equal to, here 3 into minus 286 minus plus 2 into minus 394 plus 1560 kilojoules per mole. Solve this one. Here 2 into 3 into 286, 2 into 394. What you will get? 286 into 3. 3 6 are 18, 24, 25, 5 minus 858 minus 394 into 2, 8 plus 1560. Altogether 858 minus 788, 1648 plus 1560. So 1648 minus 1560, 86 kilojoule per mole. This will be your answer. If you practice these questions, it will be very easy. Okay. Next, look at this question. For which of the following reactions delta H is equal to delta U? Okay. Here, heat content is equal to internal energy. Here, for these two, we have a relation. That is, delta H is equal to delta U plus delta Nz RT. Delta H is the heat content, enthalpy, and internal energy. R is universal gas constant and T is temperature. Here, delta Ng is number of moles of gaseous products. Number of moles of gaseous products minus number of moles of gaseous reactants. Clear? So here in the question he is asking you, for which of the following reactions enthalpy is equal to internal energy. What is the relationship between enthalpy and internal energy? You remember this expression. Enthalpy delta, change in enthalpy is equal to change in internal energy delta U plus delta Nz RT, where change in number of moles of gaseous products and reactants. Ng. Delta means which indicates a small change. N means number of moles. G means gaseous products and gaseous reactants. So how you have to calculate delta Ng, number of moles of gaseous products minus number of moles of gaseous reactants. So here now we'll calculate first. For each and every equation, 4 equations are given, no? So for these 4 equations, we will calculate first delta Ng. So what is delta Ng of first equation? Here number of moles of gaseous products. How many number of moles of products? Here it is equal to 2 minus gaseous reactants. Here these 2 are in the gaseous states, no? This is also in the gaseous state. So 3 plus 1, 4. So which is equal to minus 2. So this is not your option. Because this will be minus 2, no? These 2 are not equal. And here for you look for the second equation. Say for this is for A and this is for B. Delta Ng is equal to number of moles of gaseous products. 1 plus 1, 2 minus 2, 0. So if delta Ng is equal to 0, then delta H is equal to delta U. Okay. Now we'll see other equations too. See. Number of moles of gaseous products. So delta Ng of third equation is equal to 2 minus 3, which is equal to minus 1. Now you calculate for the fourth one. here it is delta Ng of the fourth one is equal to 1 minus 2, that is equal to minus 1. So if delta Ng is equal to 0, so here this expression will become delta H is equal to delta U. This is true in the case of the second equation. So in the case of this equation, so your option will be B. See, such a simple way you can solve any problem. If you remember a simple formula or the simple concept, you can solve questions easily. Okay. So here this was asked in 2018, April JEE 2018. So here what you have to remember is, here I told you another. Now I have introduced one new formula to you. It is delta H, change in enthalpy, is equal to change in internal energy plus delta Ng RT. Simply if you remember this relation, you can solve this question very easily. Okay. Now we'll see another question based on this. Okay. Now look at this question. The difference between delta H and delta U. Difference means delta H minus delta U. He has given that also. When the combustion of 1 mole of heptane, combustion of 1 mole of heptane, he has given, it is in the liquid form, is carried out at a temperature T is equal to. Now what is the relation between delta H and delta U? Here, by looking at this, you have to remember the relation. Delta H is equal to delta U plus delta Ng RT. This should come in your mind. Okay. So now, what is the question? Combustion of heptane. No, he is asking heptane. Heptane means here it is C7H16. Okay. When this hydrocarbon is combusted, it is in the liquid form. He has given that also. So when this is when C7H16 plus O2 gives rise to CO2 plus H2O. I told you, no, what are the products. So here balance this equation first. 7, first look at the carbons. 7 carbons. Now then hydrogens, 16 are there, 8. So altogether how many oxygens are there? 14 plus 8, 22. So 22 means 11. 2 11s are 22. That's it, no? Balanced. 7, 8, 16, 14, 8, 22, 11. Okay. Now, he is asking you the difference, no? What is the difference? Difference is equal to delta H minus delta U is equal to delta Ng RT. Now, what you have to do? You have to find out first delta Ng. So, here liquid, water. Here it is a liquid. Here it is a gas. It is a gas. So, here what is delta Ng? Number of moles of gaseous products. Moles 7 minus 11, which is equal to minus 4 RT. That's it. Okay. This is for today, and in the next 2 days I'll definitely come with some more interesting and difficult questions. Okay. Till then, bye.